Hey guys, let's start talking about sine and cosine of specific values. Today we're going to talk about a special right triangle that you learned about previously. We can see that here, that 45, and 90. We also call this the pi over 4, comma, pi over 4, and pi over 2, of course. And that's because, remember, 180 equals pi. So then 45 is a fourth of that, so we call that pi over 4. Anyway, from this angle, that pi over 4, 45-degree angle, remember that the two side lengths were the same, so we called them 1, right? If they had a ratio of 1, then the hypotenuse was a root 2. Well, that tells me that the sine, which is opposite over hypotenuse, was 1 over the root of 2. We know that we have to rationalize that, so we're going to put that root 2 on top and bottom. We end up with root 2 over 2. Okay, and if I'm looking for the cosine of that, I know cosine is adjacent over hypotenuse, which is also 1 over root 2, which I already know because I did it above, rationalizes to root 2 over 2. So we see that cosine pi over 2 and cosine and sine pi over 2 are the same value. That tells me that as we're going around the circle, if I have a radian value of pi over 4, which I can see here, okay, so if this is 0, pi over 4 is halfway to pi over 2, so it's a quarter through all of pi. That's our 45 or pi over 4. We know that this point is x comma y, or cosine theta comma sine theta when we're talking about the unit circle. This means that our cosine value that we just found of pi over 4 is root 2 over 2, and our sine value is also root 2 over 2. So let's keep going around the circle. We already know if this distance here at 0 degrees is 1 comma 0. At the top here at 90 degrees, or pi over 2 is also 0 comma 1. At pi radians, this is negative 1 comma 0. At 3 pi over 2 radians, this is 0 comma negative 1. Okay, so let's see, what would it be if I looked at here? Well, I know if this distance to pi over 4 is over root 2 and up root 2, so this distance here for x is root 2 over 2, and this distance is here, how would I get, let's say, down to here? Well, I know if this is still a pi over 4 angle, that's like saying 2 pi minus pi over 4, we would call that 7 pi over 4. This triangle is the same as this triangle, so I'm going to the right, or x value of root 2 over 2, and down root 2 over 2. Okay, so I'm almost kind of flipping this triangle over this x-axis here, so it flips down right here. So if I took this triangle and I flipped it over to this one right here, where I know if that's a 45-degree angle, aka pi over 4 angle right here, we call this 3 pi over 4. This would also be a root 2 over 2 in the left, though, so we'd say negative root 2 over 2 and up root 2 over 2. So we would say negative root 2 over 2, comma, root 2 over 2. And then lastly, in the third quadrant, we know we go to the left, which is negative, and down, which is also negative. So negative root 2 over 2, comma, negative root 2 over 2, and that would be at 5 pi over 4. And the way that we count through this is if this is half a circle, that half a circle is cut into 1, 2, 3, 4 pieces. So we count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, so if I know that around the circle, as I'm using this to find specific values, so like sine pi over 4, well, I know pi over 4 is right here, and sine is the y value, so I know it's root 2 over 2. Okay, the next one, I know we're looking for cosine of 3 pi over 4, so I'm going to find 3 pi over 4, go to cosine, which is the x value, and that's negative root 2 over 2. Okay, at sine of pi, so I'm going to find pi. The sine value is the y, which is 0. For number 4, we've got cosine of 7 pi over 4, so I'm going to find 7 pi over 4. Cosine is the x, and we see that's positive root 2 over 2. at sine negative 3 pi over 4. So we're going to go negative 3 pi over 4 would be at the same point as 5 pi over 4. And so sine is the y value, which is negative root 2 over 2. And lastly, cosine of negative 7 pi over 4. So again, we go negative 1, 2, 3, 4, 5, 6, 7, which is, if this is negative 7 pi over 4, then the cosine of that is positive root 2 over 2. Okay, now it's time to move on. So now we're talking about that 30, 60, 90 special triangle that we learned before in geometry. So remember, this would be like our aka our 30 degrees, here's our 60 degrees, right? So across, this is our short side, so that's our 1. The hypotenuse is the double, and the long side is a root 3. So that tells me from pi over 6, so that's going to be my angle here. If this is my sine, I know it's opposite over hypotenuse. Well, that's 1 over 2. So I know 1 over 2 is sine of pi over 6. If I'm looking at that, then I also know cosine from this angle is adjacent over the hypotenuse, which is root 3 over 2. If I look at that from the other angle, or the 60 or pi over 3, I would now call this my opposite side. So the sine would be the opposite over the hypotenuse would be root 3 over 2. And the adjacent here would be 1 over the hypotenuse of that angle would be 1/2. So what do we notice? I see that there's this relationship that like sine of pi over 6 and cosine pi over 3 is both 1/2, and sine of pi over 3 and cosine of pi over 6 is root 3 over 2. This is called the cofunction property, where sine and cosine of complementary angles are equal to each other. So let's use what we just learned and put it all over the circle. So keep in mind, here, let's say here's our pi over 6. That's like a 30-degree angle. That's right here, okay? So if I know that, remember that our x comma y is cosine comma sine. So what do we know about a pi over 6? Well, I know the cosine of pi over 6 is root 3 over 2, and the sine is 1/2. Well, can we find that everywhere else around the circle in other quadrants? So if here's my pi over 6 angle, here it is right here. So see, if I took this and I just flipped it over, I know like this, I went over root 3 over 2, I'd be going to the negative root 3 over 2, and then up 1/2, so I'm also going up 1/2. So here, I know this is negative root 3 over 2 in the x direction, but also positive 1/2, and that we would call that our 5 pi over 6 in radians. We also see that repeated here. So if I took this angle and I flipped it down right here, I know this is also that pi over 6 or 30 degrees. So I know that's over negative 3 pi over 2 and down 1/2. So over root 3 over 2 and down 1/2. And we call this, if this here is pi, that's also 6 pi over 2. So one more would be 7 pi over 6. I should say that again. This is 6 pi over 6. So this is 7 pi over 6. Okay. And then the last one that we're going to flip that over to is we're going to take this triangle, and flip it over here to right here. So I know I go over root 3 over 2 and down 1/2. So positive root 3 over 2 comma, 2, and this is down 1/2. And we know that this is also that 30-degree angle. So since this here is 2 pi, that's like saying 12 pi over 6. So if I back off 1, that's 11 pi over 6. Okay, so those are all of our pi over 6 angles, aka 30 degrees. So let's look at this one here, okay? So remember this one, this is like your 60 degree or pi over 3 angle. So if I'm looking at that, I know our cosine is over 1/2 and our sine is root 3 over 2, which also makes sense because these are really the same triangle, just one is on its side. So if I know the short side is going to be the 1/2 value and the tall side is going to be the root 3 over 2. So if I take that now and I flip it over the y-axis, I see that here we have the same thing. This is not pi over 3 anymore. This is 2 pi over 3. And so I know I'm going over negative 1/2 and up root 3 over 2. If I take this one and I flip it downwards right here, so in the x direction I'm going negative 1/2, and in the y direction I'm going down root 3 over 2. And we know that's a pi over 3 past the pi, so we call that 4 pi over 3. And that's this one right here. And then lastly, in the fourth quadrant, I know we're going to go over 1/2 and down root 3 over 2. And the way we name that, we know if this is a full 2 pi, that would be equivalent to 6 pi over 3. So 1 pi over 3 past that, or before that, is going to be 5 pi over 3. We're going to use that circle to fill in some values. So again, sine of negative pi over 6 is right, negative pi over 6 is right here. So sine is that y value, that's negative 1/2. Cosine of pi over 3, let's find pi over 3. And cosine is that x value was 1/2. Number 9, sine of 2 pi over 3. So 2 pi over 3 is right here. Sine is the y value, that's positive root 3 over 2. Number 10, cosine of 5 pi over 6, that's right here. And the cosine value is the x, so that's negative root 3 over 2. Cosine of negative pi over 2. So remember, pi over 2 is up here, so negative pi over 2 is going to be going the opposite direction, same spot as 3 pi over 2. And this point here, we saw on the other one was 0, negative 1. So we know that cosine value is 0. And then sine of 4 pi over 3. So if I look at 1, 2, 3 pi over 3, here's 4 pi over 3. And the sine of that is the y value, negative root 3 over 2. Okay, this is the complete unit circle. We're going to have a bunch of different ways that you're going to memorize this. If you notice closely, there's a pattern. If you see here, at this starting here at this x value and y, if I look at this y value 0, 1/2 root 2 over 2, root 3 over 2, 1. And then we see that pattern to happen again, starting at the x value 0, 1/2 root 2 over 2, root 3 over 2, 1. So there's a lot of patterns in this graph, or in this chart. We are going to teach you different ways in class to memorize it, and you will be having a separate test on it. For now, go ahead and that'll be the end, and I'll see you in class.